Hello and welcome to my Make Everything machine that's fully automated in Shapes.io. I've spent roughly 10 hours over the last 2 days building this thing, so I figured I wanted to share it with the world. I will go through each part of it in a walkthrough tutorial kind of way, so hopefully you can even learn something from this video. So first, of course, we have to extract the shapes, and I'm using quad cutters to cut them into and rotate the shapes so that I get one for each shape, each corner, each layer has an input, so I get this 64 channel input matrix into my filters that work on logic that we'll get to after the analyzer. So the hub outputs the shape we need, and I split that shape into layers using these demergers or whatever they're called. So basically you need 3 of those for a full 4-layer shape, because the last one, of course, outputs the bottom layer as the left input, left output, right output always outputs the top layer. So right output outputs the top layer, and then the analyzer always analyzes the top right corner. So we'll need to rotate the part to get every corner analyzed, which is what these rotators do. And then after that I cut the shapes and rotate them back so that the corner I've analyzed is in the correct position again. So basically, other than the top right corner, I have to rotate everything as many times, or 4 times in total. So if I rotated it once down here, I'll rotate it 3 times up here. So that's the analyzer. I have displays showing what the outputs are. So here we have a mostly gray shape, which is why many of the displays for color are empty. But here we see what we're working with. So that then sends signal to my filter, in which I have comparers comparing the signal to set shapes for space reasons. I did try to read the belts first, but that was difficult to accomplish in such a small space. So when this shape is output, it's the top right circle. Only the circle belt will flow through the filter, and all of the other ones will be trashed. So we see here the output is correct. And then I have these overflow gates, because otherwise the cutters will get stuck. And the reason I have these NOT gates here is because if we go to this higher up one, which doesn't have an input, we see no input to the comparer means no output from the comparer. So I have to use NOT gates so that it actually outputs a 0 and doesn't just lock the filter up again, leading to problems with the cutters. And from the filters we output into the mergers. And here I have some logic with basic AND gates checking. Do I need a shape from both of these lanes of input? If not, they will get the other one will get bypassed here. Of course, the other one doesn't get any input from the filter in the first place. And the same for the top one. And these OR gates in combination with this AND gate check if I have any input on either of these two lanes and either of these two lanes. Even if it was only one input on this lane and this lane, they will... oh, there's a mistake. These will get output to the bypass and that, and then here I have another bypass for basically if I need only the top two shapes, only one shape, only one part of a shape. These filters will bypass the second merger. Otherwise, as it is now, I need a shape for each. I need a part for each of these, so they just get sent through every merger. And here I have some basic logic to check that I'm actually getting the correct shape. And this is not perfect, it will sometimes output correct shapes. Or sometimes trash correct shapes and let wrong ones through because apparently there's some room in between here. So if an incorrect shape comes into the reader while a correct shape is going into the filter, the correct one will go out. And then when a correct one comes into the reader, it will output the wrong one. So yeah, I don't know how necessary that part is, but I figured I wanted an error correction and it didn't work as well as I thought. Then we'll get to the painters, so let's start with the mixer. So from the analyzer, colors get output to the right and into these color mixers. So here I have a bunch of filters. And we'll see this one is currently outputting gray, so there's just leftovers from the previous shape. Since all of the bottom ones are outputting gray, so let's go to one that actually outputs something. So here we see we need yellow. So that means first we have basically blue and green going into the first color mixer. But since we don't need cyan or white, these filters are turned off and they send the blue and green to the bypass. And since I don't need to mix blue with anything and the output isn't blue, it's yellow, the blue gets trashed. While the green gets sent through because I need yellow, so I can't trash the green. So here then I check for the red filter if I need to mix red with anything. So I need yellow, white or pink. Then the filter turns on and red is output to the mixer. If I don't need those, it gets output to my bypass lane, so I can output red with this filter or just trash red if I don't need it, which we do here. For example, you see I don't need to mix blue with anything, so it gets to the bypass and gets trashed. Same for green, same for red, because I only need yellow and gray for this shape. So then we actually get to the painters. So here each layer, the color for each layer gets compared with gray. So here we see, actually this is perfect, we see that all of the corners of the top shape need to be gray. So every comparer outputs 1, and with these NOT gates I turn them into zeros. So we see the painter is not working. Now that's an issue, because that means it doesn't output a gray shape, which is why we have these these 3 AND gates checking yes, every lane is active, and then I need this NOT gate because it's more convenient to put the filter in this way, so that bypasses the entire painter and gets sent over here. And in the case of the bottom shape, we see that it outputs 1 on corners 1 and 3, so only the red gets painted, the blue stays here, because that's just leftovers from the previous level. So then to the final assembly, where basically I check whether anything on the bottom 2 layers actually is supposed to have a shape on it. If not, this XOR gate will activate, or rather deactivate, these 2 filters, so that the shapes can just bypass the first 2 mergers and then merge here in the final merge. And then similarly I use XOR gates to check, do I need both of the top 2 layers or both of the bottom 2 layers, and if not, these filters will let the shape bypass over here. Apparently I've done a mistake, so now it's correct, and then they will get output into the merger here. And then, because this is the topmost layer, it will be the only layer used. If there's only one layer, this machine will count it as the top layer. So that's why I only have a bypass for the top one, again using an XOR gate like previously, this time with a NOT on it, because the filter was more convenient to put in this way. So yeah, there you have it. Let's just let this output, and you'll see very quickly this belt reader is outputting 14, so nice, we got that shape done. And it has already analyzed the next shape, knows what to do, it keeps trashing the wrong parts until we start getting the correct ones. So here we're still outputting actually the same shape as last time. Here we're starting to get in the windmills, and after a while the incorrect colors will start to get weeded out. There we go. No more incorrect colors coming in. So after all of the wrong colors have been used out, this output filter will start letting letting shapes through. There's the first ones coming in. So yeah, that's it. Hopefully you enjoyed and hopefully you learned something. Thanks for watching.